So in the last video, we did some vertex displacement with our shader graph here. However, our material here is becoming a little bit of a mishmash between a whole bunch of different effects, and we might not want them all. Sure, we could just simply turn them on or off by controlling their values, but Shadergraph is still doing the math for every single operation anyways, even if we set multipliers to 0 or anything like that. So we want a way of controlling what the shader does in an optimizing way. So how we're going to do that is we're going to use keywords. I talked a bit about keywords in my HLSL series, but it's a little bit complicated understanding keywords there. Basically, a keyword is a preprocessor directive that tells the shader to only compile things that have the keyword being true in it. So if there is a keyword section, only if that keyword is true does that part of the shader code get compiled. In Shadergraph, it's a little easier to understand. So let's create a Boolean keyword, and we'll call this use displacement. And we can drag this into our scene here. And what you'll see is that it's creating a function here that has an on and an off, and then an out. So this use displacement keyword, we have it set here. Here's the reference if for some reason you need to set it in code. But there are different options here, like we had where we could have a shader feature or a multi-compile. If you're curious about what those are, I explain them in my HLSL series. But basically, shader features, they'll only be built if the shader feature actually exists in the project at the time of building it. Multi-compile will always build all variants of the shader. So shader features are generally more performant in your build. Your build won't take as long because it might not have to compile millions and billions of versions of shaders. Keep in mind, the more keywords you have, the more complicated and the more number of shaders need to be compiled. It's better performance-wise, but your build can take significantly longer if you use a lot of them. You are also limited to a maximum of 255, and Unity already uses about, I think, 60 of them. So don't go absolutely over the top using a shader feature for everything in your for your entire project, but they are really useful ways to improve performance. So since this one here is use displacement, what we can do is we can say that if true, we'll take our modified displacement value here. If false, we just want to take the original position of the vertex in object space. And then what we do is we apply it to our position here. So what this is doing is it's basically saying, okay, if I'm on, include all the nodes that are attached to on. And if we go backwards, that would be this one, all the way back, including our noise and everything. So it would say, okay, create a version of the shader with all these nodes in it. However, if it's off, it only needs to go from everything that connects to off. So it would just create these two nodes. So it's a way of improving performance because with it off, the shader is actually getting rid of this entire chunk internally. So it doesn't need to have any of that extra math if it's not doing anything. So let's just quickly save that. Now we can go to our material, and we have a Boolean down here that we can say use displacement. And it will take a second the first time you click it because it has to compile the new version. Since this is a shader feature, it won't compile them by default. And now we have two versions, one with our displacement and one without. So we can create another shader feature. Let's go keyword enum. So for this one, the enum keyword, we're going to say smoothness metallic mapping. And this one here, we're going to have some different entries. So this one is going to be no maps, smoothness map, metallic map. We'll create one more for smoothness metallic map. We're going to use this keyword to control our smoothness and metallic mapping. So before, right, I showed you how to use a texture for our smoothness and metallic map. So in this case, what we're going to do is we're going to make ways of using either no maps at all, and it just will go based off of these values. We'll have one with just a smoothness map, but use the value for metallic, just a metallic map, but use the value for the smoothness, and use a smoothness metallic map for both. So how we're going to do this is we're actually going to combine these into vector 2s. So I'm just going to delete these two for now. I'm going to take these and I'm going to put this in as a vector 2 for the x value and the y. So this is the case of not using any maps. We just want to directly feed those two values. If we want a smoothness map, then what we need to do is we need to multiply our smoothness by our channel here. And then we'll put that into another vector 2. And this one, we just want to feed the metallic directly. So this one, we're using a smoothness map, but a metallic float. We want to do the same thing with our other values. So we want to take our metallic, multiply it. I always accidentally put it into B. Multiply it by our channel value. And then we're going to feed this into another vector 2. And we want to take just the smoothness. So we have just a metallic map. And then we want to create one with both of our maps. So we have vector 2. And we want the smoothness to be our x, and the metallic map to be our y. I'll actually move this down here. Now we have our different mapping. So I'm just going to rearrange some stuff quickly here so it's hopefully a little less Shadergraph spaghetti. But now we have our enum keyword going. So basically we feed it in either none of the maps and just the floats, the smoothness map and the metallic float, metallic map and the smoothness float are both maps, and they're stored as vector 2s. Now what we can do is we can take the out here and we can split it. And we know that the X channel is our smoothness and the Y channel is our metallic. So this is a way of, while this isn't a simplification in terms of optimization, this is a way to basically have our values work in different ways. So it's an easy way to make it so we have multiple different modes for how this shader should work. So now if I save that and we go to our scene view here, now we have a no maps value. And this is what we were working with before, where we weren't using a smoothness or a metallic map. I'm just going to quickly set our emission to 0. But if I set it to use a smoothness map, it'll have to recompile the shader quickly. What you'll see is that our smoothness is being applied as the texture, so it's only really smooth at the peaks and the bright points here. If I change it to metallic, you'll see that the whole surface is going to be smooth and shiny. However, it's most metallic at the tips. And if I have it set for both, then it's only smooth and metallic at the tips. So this is a way of creating those different effects using just a keyword, and I find it works quite well. We're going to create one last keyword here, and we're going to call it, we're going to make it a Boolean, and it's going to be use emission. And this one's a pretty easy one. We just want our on to be our emission value and our off to be 0. And this we will just feed into our emission property. And before, when I had to change the emission to be dark so we couldn't see it, now I can set our emission value And only when this boolean is on is there any emission on the surface of the material. So this is a way to control that. And it does simplify it because in our actual shader, we're using a noise texture and everything here. So without it, we don't need to actually have any of this included in our shader. So keywords are generally great ways to optimize. They also help with cleaning up for having different modes, like what I showed here with the enum keyword. So use keywords when you can. Don't go too overboard. But if you're having a really complicated Uber shader that has a whole bunch of different functions and you're going to use it for basically every material in your project, enums are a great way to go to reduce complexity and to make it much more controllable. So in the next video, we're going to look at doing some animation with Shadergraph.